All right, today we're going to be continuing on and adding to our knowledge of slope of a line. So we've been working with linear equations. And remember, linear equations are just equations that I can use to plug into to plot my line. So it's just the equation of the line. It's just another way to describe that line on the graph. And then we're going to be talking today about the Y-intercept, which is where my line crosses the y-axis. So this is where my line crosses the y-axis. My paper is bumping. There we go. Sorry about that. So we talked about slope-intercept form. And when we have a proportional relationship or a proportional equation and it goes through the origin, our equation looks like this: y equals mx plus b, where y and x, those are the coordinates for a point on our line, for all the points on the line, and then our slope is the m, and that tells us at what rate it's changing. Is it changing quickly? Is it changing slowly? Is it a positive change where our graph is going up? Is it a negative change where our graph is going down? So this is the piece we're going to add in today. When our line does not go through the origin, I'm going to have something added onto it, or you can, and that's just where you can think of it as adding a positive or adding a negative. But that's going to tell me where I go through the y-axis. So if I don't go through at the origin, for this part right here, if I went through at the origin, my line might go through like this. When I don't go through at the origin, my line might look something like this. And you can see it misses the origin, but it still goes through the y. It's just off a little bit. So once again, m is going to be the slope of the line, and the b is the y-intercept. So that is the point where the graph of a line crosses the y-axis. In the ordered pair, when the point's right on the y-axis, that means that the x has to be 0. And then the y will not be 0. So before we would have gone through with the origin, it would have been 0, 0. If we're going through on the x-axis somewhere else other than the origin, then we'll have the point 0 and then y. So to write an equation in slope-intercept form, I have to know a couple things. First thing I do is I have to find the slope of the line, the m. So first I have to find the m. Then I have to identify the y-intercept, the b. So this is where it's going across. So if it's going across at 0, I would just be adding 0. So that's why we just get rid of that. But since I don't know where it's not, since it's not going across the origin, that's why I'm adding something. So once I have these two pieces, I can put my y and my x back in, and I'm able to write my equation. So on this first one right here, I'm going to find my slope. Remember, it's rise over run. And I like to pick points that hit perfectly. So I'm going up 1 and over 2, and since it's rise over run, I went up 1, so my rise was 1, and then my run was 2. My y-intercept happened to be one of the points that I used for my rise over run, and my y-intercept is at -3. So when I go to write my equation, my y and my x are there. I found that my slope was 1/2, and I found that my y-intercept was -3. Our next one here, we notice it's not going through the origin again. So I'm like, where's it going through? So it's going through at that point right there. So this time I'm just going to find my y-intercept first. So it's not going through the origin. My y-intercept is at the point +1. Then I want to identify my rise over run. And to get to my next point there, I'm going to go up 1, 2, 3. So I have a rise of 3 and a run of 1. So my slope is 3. So when I go to write my equation, my slope goes here. My slope is 3. And this was a +1 for my y-intercept, so I put +1, and that's how I write my equation. For my next one here, I've got my y and I've got my x. I find my y-intercept is at 1, 2, 3, 4. Now my rise over run this time, you notice it's going down. So when it's going down, that means my slope's going to be negative. So when I count down, I'm going to go from here to here. I'm going to count down 1, 2. So since I counted down, I think of that as a -2. And then I go over 1, so my slope is -2. So -2 plus 4, and that's the equation that describes that line. In other words, if I picked an x out and put it in here, evaluated it, I would find my y, and then I could go and graph my point on my line. Graph several of those, and then I can draw a line to connect them. The nice thing about adding in that y-intercept, if I know the y-intercept and the slope, I can graph. Alrighty, moving on to the word problem there. We see that the line model in this graph represents the relationship between temperature in degrees Celsius and degrees Fahrenheit. And I go over here, and it's hard to see, but they've marked it for me. They've given me my y-intercept. So since it's at the point 0, 32, this is my y-intercept. So my y-intercept is going to be +32. Looking for my slope on this one, it might be kind of hard to count, but they've given me 2 points. And so if you remember, you can find your slope by doing y sub 2 minus y sub 1 and x sub 2 minus x sub 1. So these are my 2 points. So I'm going to call this one point 2 and this one point 1. So I'm going to use this y, 104, and I'm going to subtract 32. And on the bottom I have 40 minus 0. When I subtract these, I get 40 minus 0 is, of course, 40. And 104 minus 32 is 72. You'll notice you can reduce those. You can divide those both by 8, and so you will get 9/5. So that means my slope is 9/5. So now I'm ready to write my equation. I have y equals some x times 9/5 plus 32. And in science, you'll see this written as your degrees Fahrenheit is equal to 9/5 times your degrees Celsius plus 32. And so it says, what does the y-intercept represent? Well, the y-intercept represents that when it's 0 degrees Celsius, then that is 32 degrees Fahrenheit. So freezing in Celsius is 0 degrees, and 32 degrees Fahrenheit is what we consider freezing, and that these are the same thing, that they're equal. The slope represents that for every increase of 5 degrees Celsius, the degrees Fahrenheit rises or increases by 9 degrees. Moving on to our back here, we're talking about graphing equations. So if they're giving us our equation in slope-intercept form, and we're going to graph that. So I can use that to graph that, and this is very handy. It makes it pretty quick. We just need to make sure that we know how to recognize all the parts. So to graph given an equation in slope-intercept form, we're going to start at that y-intercept. It's a really easy point. It's that place on the graph where x equals 0, and then we have the y. So we can just go right up and plot that point. And from there, we're going to go from that y-intercept, and we're going to move the point. And if the slope is positive, you will go up and to the right, or you will go down and to the left. Now, if the slope is negative, you will go down and to the right. So either up and to the right or down and to the left. This one we're going to go down and to the right, or we are going to go up but to the left. So you can kind of see how those lines point in those ways. Continue to plot points until you can make a line. Now note that you really only need 2 points to make a line. So if you get the y-intercept and one other point on there, you can connect those and make a line. So you really only need 2 points to do that. And then make sure that you put arrows on both sides of the line, because remember that a line really truly goes out in both directions. So here we have to just identify this is our slope. There is our y-intercept. So my slope is telling me to move. It's positive. It's positive. So I'm going to move up 2. And I'm going to go right 3. I'm also going to demonstrate it going down 2 and left 3, and I'll show you how those end up on the same line. So my y-intercept is at -3. So 1, 2, 3. So there's my y-intercept. Now I can go up 1, 2, and over 1, 2, 3. Or I can go down 1, 2, and over 1, 2, 3. And you'll see here, I should get my ruler out, I can connect those points in a straight line. I put arrows on both sides. Over here, I've got an x-intercept, I've got a slope of -1/2 and a y-intercept of +2. So my slope is going to move down 1 and to the right 2, or up 1 and left 2. So my slope-intercept, or my y-intercept rather, is at +2 on this one, and I'm going to go down 1 and over 2, or I can go up 1 and over 2, and you'll see because it's negative, we think of that line as moving down. My last one here, I've got a slope of 3, and a y-intercept of 4. And so that slope is going to move up 3, and it's like there's a 1 underneath there. So to the right 1, or down 3 and to the left 1, because it's positive. So I'm going to go put my y-intercept there at 4. I can go up 1, 2, 3, and over 1, or I can go down 1, 2, 3, and over 1. Positive slope, so my line is going like that. Going to practice some more of these in your homework and let us know if you have any questions.